Identify the type of titration. The curve represents the titration of a weak monoprotic acid with a strong base, lithium hydroxide, LiOH, produced from the reaction of Li with water. This is indicated by the moderately acidic starting pH, approximately 3.4, the flat buffering region, and a basic pH at the equivalence point. Locate the equivalence point on the pH curve. The equivalence point is represented by the midpoint of the sharp, nearly vertical region of the titration curve. Looking at the horizontal axis, this steep rise is centered at exactly 25.0 milliliters of base added. Determine the volume at the half equivalence point. The half equivalence point, or midpoint of the buffer region, is the point at which exactly half of the volume of strong base required to reach the equivalence point has been added. V half equals 25.0 milliliters over 2 is equal to 12.5 milliliters. Relate the half equivalence point to the pKa. At this exact midpoint, exactly half of the initial weak acid, HA, has been neutralized to form its conjugate base, A to the power negative, meaning their concentrations are equal. HA equals A to the power negative, applying the Henderson-Hasselbalch equation. pH equals pKa plus log A to the power negative over equals pKa plus log 1. Therefore, pH equals pK. Thus, at the half equivalence point, the measured pH of the solution is equal to the pK of the weak acid. Estimate the pH value from the graph. Find 12.5 milliliters on the horizontal axis, just to the right of the 10.0 milliliters line, and trace it vertically to the curve. The corresponding pH on the vertical axis is approximately 4.7. Among the given choices, this value is closest to 5, confirming option B as the correct answer. The correct answer is option B, 5.